Alright, so let's get to it. You guys do have an assignment, and I would like you to maybe be able to get started on it. So you remember when we were factoring? Hey! You remember when we were factoring, we talked about perfect squares, and I had them listed on the sideboard there for a while. What is 1 squared? That's a perfect square, because if you take the square root of 1, you get a pretty little whole number. You get 1. What's 2 squared? 4. 4 is a perfect square, because if you take the square root of 4, you get a pretty little whole number. You get a 2. Keep going. 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? Oh, well, I just figured everybody knew this. Okay. 11 squared? 12 squared? 13 squared?
130, 156, just kidding, 164, 162, 163,
169. 14 squared?
240 something.
It flips these two around.
296, 196.
196.
214.
No. 15 squared.
225.
Okay, those are the ones I would like you to know.
I thought that one was 248. 14.
No. If I showed you 14 squared, or 14 times 14, however you want to put it in your calculator, you get 196. So I would like you to know to the 15. I don't care that you know to 25.
So can we just put a big X through them?
I know 2,500. I mean, 1,000. Wait, what? Never mind.
Wrong.
25 times 25, 625.
Can you go down?
I was thinking of
Okay, so these are the ones that I would like you to know. These are called perfect squares, which we talked about when we were doing factoring with the difference of squares. Okay, so first we're going to look at some easy examples. If we can take the square root of it and get a pretty little whole number, then I want to do that. So, square root of 25 is what? 5. Okay, number 2, I'm going to skip that one for right now. Looking at number 3. Ignore the 2. What's the square root of 144?
12.
It's just a pretty little 12. The 2 that's out in front, do you see how it's smushed with it? That means I want to multiply the 2 with the 12. And 2 times 12 makes? 24. Okay, let's look at number 5 before I go to number 4. Looking at number 5. This is something that you haven't done before, but as long as you have 2 numbers under square roots, you're allowed to multiply the numbers under the square roots. So what is 11 times 3?
33.
So the square root of 11 times the square root of 3 is the square root of 33. Is 33 one of the perfect squares that we wrote up above?
No.
So you can't take the square root of it and get a pretty little number. So I'm just going to leave it like that for now. Okay, I want to go back to number 2. We do not have 441 in our list, but that doesn't mean you can't take the square root of it. So I want to make sure everybody knows where the square root is in their calculator. Do you guys know where it is?
Absolutely.
Second math or something like that.
It's 21.
I will do second something. Second.
Second squared.
Good. I'm going to go second x squared.
Oh, something.
Second x squared and 441. And then if I hit enter, I get 21. So the answer would be negative 21.
And on 60, just to 25.
Yeah, I'll show you. Okay, so looking at number 4. As long as you're both under square roots, you're allowed to multiply them. So what's 3 times 3? So the square root of 3 times the square root of 3 is the square root of 9,
3.
which is just a pretty little 3. Because 9 is a perfect square, so I can take the square root of it and get something nice and pretty. Looking at 6. Square root of 5 times square root of 5 is square root of 25. And what's the square root of 25?
5.
It's just a pretty little 5.
Is it going to
Okay.
be like that with a lot of them where
Yeah.
you multiply by the same square
Yeah.
roots that you'll
So I want to show you before we move on. Square root of 6 times square root of 6 is square root of 36. What's the square root of 36? Okay, so Evelyn was noticing something up here. Are the rest of you noticing?
Yeah.
When you're working with square roots, as long as you multiply by 2 of the same thing, out it comes from underneath the radical.
What?
So I multiply by 2 of the same thing that's under the radical, and out it comes from underneath the radical. So if I just asked you, what's the square root of 242 times the square root of 242, the answer is 242. As long as you're working with square roots and you multiply by 2 of the same thing, out they come, and the answer is 242. If I said, what's the square root of x times the square root of x, what would it be? It's just x. Multiply by 2 of the same thing, shoop, out he comes. Okay, before I flip the paper, I want to come back up here and add in a couple more examples. Okay, if I gave you square root of 36 times square root of 9, now I could multiply these two together first, 36 times 9, and do it that way, but do you notice how they're both perfect squares right now?
Oh yeah.
So I could actually work it a little bit easier. What's the square root of 36? 6. What's the square root of 9? 3. And 6 times 3 makes, so the answer to that problem would be 18. The other way I could do it is I could multiply the 36 and the 9 together, because they're both under the square root, get the square root of 324, and if I don't know what the square root of 324 is, I can make my calculator help me, and I see that I get 18 that way too. So I can multiply the 36 and the 9 together, like I did on number 5. I multiplied the 11 and the 3 together. So I could do that, or since they're both perfect squares, I could work them out and then go. Who had a question? Oh, I thought I saw a hand up.
No, I was searching.
Okay, if I gave you negative square root of 49 times square root of 25, so I could multiply the 49 and 25. I could do that. Or, are they both perfect squares?
Yep.
So let's just do it a different way. What's the square root of 49? 7, and then the negative would just drop. And then what's the square root of 25? 5, and so the answer would be negative 35. Okay, so let me give you one to do real quick. Take the square root of 100 and multiply it by the negative square root of 4. So square root of 100 times negative square root of 4. Tyler, pay attention. You're off in outer space.
Wait, 4?
Square root of 100 times negative square root of 4.
Wait, why are we doing all these?
Can you?
Because I want to.
There's no reason.
Okay, Evelyn, what'd you get?
Negative 20.
Negative 20. So you can do it a couple of ways. The square root of 100 is a pretty little 10. The square root of 4 is a pretty little 2. The negative would drop, and 10 times negative 2 makes negative 20. But I could multiply the 100 and 4 together and have square root of 400, a negative 400, and then do it that way. Okay, before we flip the page, I want to do a few others. So these are going to be adding. So square root of 49 plus square root of 144. So one thing I want to tell you about adding radicals. You only can add radicals if these two numbers are the same. These two numbers aren't the same, so I technically can't add them. But I can simplify them. What's the square root of 49? 7. What's the square root of 144? 12. And 7 plus 12 makes?
That's a very good question. 19.
19. So that would be the answer. So as far as multiplying is concerned, they don't have to be the same underneath to multiply them. You can just multiply the numbers as long as they're both under a radical. But to add, they have to be the exact same number underneath in order to add. So if they're not the same number underneath, we have to see if we can do something else. And this one I could actually just break it down nice and pretty. So like if I gave you the square root of 64 minus the square root of 16, as of right now, I can't actually subtract these because these aren't the same number. But I can simplify it. What's the square root of 64?
8.
8 minus, what's the square root of 16? 4. And what's 8 minus 4?
4.
4. And that would be my answer. So, two things I wanted you to get out of this, even though we haven't really seen an example. When you're multiplying, the numbers underneath don't have to be the same. When you're adding and subtracting, the numbers underneath do have to be the same. If they're not the same, you have to try to figure out something else. What's wrong?
I don't know, dude.
Yeah, you were sitting here earlier, and you left your phone here.
I don't know how
Is that why you were, like, being
No,
weird back
I was
there?
looking over here. How many more days we have left of school?
Sit down.
I'm a 60, that's all.
Driving me crazy. Okay, looking at this. Are these both pretty? Do these look like perfect squares to you?
Yes.
Yes. So this right here means square root of the top number over square root of the bottom number. And since they're both perfect squares, this is just going to come out nice and pretty.
15 and 13.
Uh-huh. So it'd be what over what?
13 over 15.
13 over 15. Good.
And then you divide by 3 because, wait, no, you don't. Never mind. I'm kidding.
If I could simplify it, I would, but I can't simplify it, so that's it. Okay, now number 9. This is an example of adding. To add, the numbers underneath the radical have to be the same. Do you know what's out in front of this? You just don't see it?
1.
Okay, so the way it works when you're adding, you just add the outside numbers. What's 1 plus 3? 4. And then whatever's under the radical, that just recopies. You know how if you add 1x plus 3x, what's 1x plus 3x? 4x. You really only add the 1 and the 3, and then the x part just recopies. Well, this is the same way. So as long as these are like terms, you just add the outside coefficients, and then whatever the radical part is, just recopies. So what do you think number 8 would be then?
-2 square root of 7.
-2 square root of 7. All you do are the outside numbers, 2 minus 4, which is -2, and then the square root of 7 just recopies. Okay, and then number 10. Do you guys remember learning that anything divided by itself is 1? 4 divided by 4, 1. 10 divided by 10, 1. So square root of 5 divided by square root of 5 is just 1. It's just 1. And 3 times 1 is 3. It's like anything divided by itself is 1, so basically I can just like cross it out, and all I'm left with is 3. Okay, we're going to go to the other paper. And then we'll come back, and I'll talk about this a little bit more. Okay, this is where sometimes students struggle a little bit. Not all things under the radical come out nice and pretty. For example, the square root of 50 is not a perfect square. Nowhere in my perfect square list do you guys see a 50. So you can't take the square root of 50 and get something pretty. So this is when I try to find, Skylar, can you finish that up? This is where I try to find the largest number in this list that will go into 50, and then I write down how many times that number goes into 50, and then I break it down. So in that list, 25 is the biggest number that goes into 50 evenly, and it goes in there twice. And when you break it down, like what goes in there, how many times, you have to have square roots over both of those. And then what's the square root of 25?
5.
It's just a pretty little 5, so it gets replaced with a pretty little 5. And then you can't take the square root of 2, so that recopies, and that's your answer. Okay, so 98. I'm just going to start dividing by my perfect squares until I find something. So if I look at this list here, do you agree that 1 goes into everything?
Yes.
So I'm not even going to bother dividing by 1 because I know 1 goes into everything. So I'm going to start with the 4 and then the 9, etc. So I'm going to go 98. I'm just showing people, if they don't know what it is, how they can use their calculator. So I'm going to start with the first perfect square besides the 1, which is 4. Did I get a nice pretty whole number? Then that means 4 does not go in there evenly. So I go to the next perfect square, 9. Did 9 go in there evenly? Okay, so I move on and I try the next perfect square. Did that go in there evenly? No. So I keep going. Did 25 go in there evenly?
No.
So I keep going. Did 36 go in there evenly?
No.
Nope, so I keep going. Does 49 go in there evenly? Okay, now to know if you got the biggest perfect square, because that's a thing, we always want the largest perfect square that goes in. All you have to ask yourself is, can this number be divided by any of the perfect squares besides the 1? And this number cannot be divided by any of these perfect squares besides the 1. So I know 49 is the largest perfect square that goes in there. So I write square root of 49. And it goes in there twice. So I write times square root of 2. So when you break this up into what perfect square goes in there and how many times, they both need to have square roots over them. And always put the perfect square first. Now, what is the square root of 49? It's just a pretty little 7. And then you can't take the square root of 2 and get something. So I recopy square root of 2, and I'm done. Okay? All right, this next number, much bigger. So I want to show you something that happens here. So 192. If I start with the first perfect square, 4, did 4 go in there evenly? But look at this 48. Can 48 be divided by any of these perfect squares?
No.
Do any of these go into 48?
No.
4 goes into 48. 16 goes into 48. If this number right here, the answer, can be divided by any of these perfect squares, we need to keep going. That means there's something bigger than 4 that goes into 192. I want to see if you guys can find the largest perfect square that goes into 192. Take a moment and see if you can figure out what's the largest perfect square. Which one of these is the largest number that goes into 192 evenly?
Do you yell at your kids?
My own children?
Stop it.
Sometimes. What?
Thank you.
I am loud.
Right here.
Oh my
I'm
gosh.
lost.
Well, I'm loud because I have to teach a class.
Evenly? What do you
Yes,
mean?
ma'am. But
I mean, I don't talk like that to my children. I don't talk like that in a room full of, like, 2 people.
Miss Wood, what do you mean by evenly?
Like if I was talking to you, I would just be talking like this. But when I'm trying to make sure the whole class hears me, then I always project my voice.
What do you mean by evenly?
No decimal. You won't, when you divide it, you won't get a decimal answer. Are you guys trying to find the largest perfect square that goes in?
Yes.
Come on, try it. Go on, try it.
16.
Yep, but can your answer be divided by a perfect square?
This is like getting checked.
So you need to keep going. 12's not a perfect square. You're trying to find the largest perfect square that will go into 192 evenly. I want to find the largest one.
Got it.
36.
Already got it.
No, it's not.
It's 24.
Have you found it? 24 is not a perfect square.
Yeah.
Yeah, it's because it's on here.
It says it right there.
No, no, no.
No, she's saying like
These are your perfect squares. The ones I wrote in green. What's the largest number in this green perfect square list that will go into 192 evenly? Okay, so I heard 64. That's pretty big. Let's check it out. When I take 192 and divide by 64, I get 3. Can 3 be divided by any of these green perfect squares other than a 1? No. So I know 64 is the largest. Now, like when I tried 16, 16 did go in there evenly, but the problem is 12, my answer can be divided by a perfect square because I can divide 12 by 4 and get something pretty. So if your answer can be divided by a perfect square, you need to keep going until you find the largest one. And 64 is the largest one. So this is how I rewrite it. Square root of 64 times square root of 3. Because 64 is a perfect square that went in there, and it went in there 3 times. And then what is the square root of 64? It's just a pretty little 8. You can't take the square root of 3, so that one just recopies. And that's our answer. Okay, number 4. Does anybody know what the largest perfect square is without using their calculator? That would go into 90?
Yeah.
10's not a perfect square. Guys, your perfect squares are these numbers in green.
9.
What's the largest one that goes into 90? 81? Let's try. 90 divided by 81. No. 81 does not go into 90. It is 9. 9 goes into 90 10 times. Can 10 be divided by any of these green perfect squares evenly?
3 square root of 10.
No. So 9 goes in there 10 times. And then, yes, like Tyler said, the square root of 9 is a pretty little 3. You can't take the square root of 10, so that one recopies. And there's your answer. Okay, 68. Anybody think of a perfect square that might go into it? Can anybody think of a perfect square that might go into 68? And if you don't know, let's just try. What's the first one after the 1? 4. Does 4 go in there evenly? Now let's look at my answer. Can 17 be divided evenly by any of those green perfect squares?
No.
Then I know that that's the highest one. If your answer can't be divided by any of these perfect squares evenly, then you found your biggest one that goes in there. So 4 is the largest perfect square that goes in there, and it goes in there 17 times. And then what's the square root of 4? 2. You can't take the square root of 17. That doesn't come out pretty, so I just recopy it. And there's my answer, 2 square root of 17. Okay, your turn.
Wait, but I thought you were trying to find one that goes in perfectly.
I did. 4.
What is?
Oh, I thought you meant it.
4 goes in there. 4 goes in there evenly 17 times.
I thought it had to be the 17 that had one.
No. And then the square root of 4 is a pretty little 2, and then you can't take the square root of 17, so that one just recopies.
What's the point of this?
This is just, well, like with a lot of math, it's just something that's required in math class. In Algebra 2, we simplify radicals all the time. And in geometry, you have to know how to simplify radicals. And so I know that I was in a classroom the other day, and he said that he wished that he would have learned how to simplify radicals more before he got into Algebra 2, because that really kind of kicked his butt when he first got in there.
All right, Miss Wood,
I don't know who the kid was.
Oh.
I mean, he was somebody else's student. It was a comment he had made. Greg, did you find it?
25.
Okay, and how many times does 25 go in there?
5 times.
Okay, so 25 goes in there 5 times. So my suggestion to you is always write the perfect square first and how many times second, and make sure you put square roots over both of them. What would the final answer be?
5 times.
5 square root of 5.
5 square root of 5. The square root of 25 is a pretty little 5. You can't take the square root of 5 and get something pretty, so that one just recopies. So I could say this several ways. 5 times square root of 5, 5 square root of 5, 5 radical 5. So several ways I could say it.
Wait, how do you write radical?
This is a radical symbol right here. It's also a square root symbol. But this guy right here is a radical. It's also called a cubed root. This guy right here is a radical. It's also called a fourth root. If you don't see the number, it's a square root, but they're all radicals.
Would you be able to just write the 5 with the line on top?
No. Okay, I'm not going to show you how to do letters right now because you don't really need to know that. So we're just going to ignore the letters, pretend they're not there. What's the largest perfect square that you can think of that goes into 18?
9.
9. How many times does 9 go in there?
Twice.
Twice. And what would your final answer be?
3 square root of 2.
3 square root of 2. The square root of 9 is 3. You can't take the square root of 2, so that one recopies. And that would be the answer. And that's just me not showing you how to do letters. Number 8, I wanted to show you. Can you think of a perfect square that goes into 55? So if I just start my list, does 4 go in? No. Does 9 go in? No. Does 16 go in? Oh, sorry. Does 16 go in? No. Does 25 go in? No. Does 36 go in? No. Does 49 go in? No. Once you get bigger than the number you start with, there's no way it's going to go in. So you can't simplify it. I'm just going to recopy it. You can't break it down. Sometimes there's nothing that goes into it, so you stop. You know, a minute ago when we did this one, square root of 11 times square root of 3, and we got square root of 33. Is there a perfect square that goes into 33?
No.
That's why I left my answer like that. So sometimes that's your answer. Sometimes you can't break it down. Sometimes you can.
So you're going to give a bunch of kids who are slackers who just put that at all the answers, and you're going to confuse a lot of kids really smart.
How am I confusing you? I don't
No,
understand.
I'm not saying you're confusing me. I'm just saying that
You're gonna
frustrates
confuse
a bunch
smart
of
kids.
And
Why?
then kids who don't understand just get right down the answer.
Send you more than 4.
Okay. All right. Let's flip to the back. So this is talking about something I said a minute ago. When you're multiplying, they don't have to be the same number underneath. When you're multiplying, they can be different numbers underneath, and you just multiply the numbers. 2 times 3 is 6. And so since it's square root of 2 times square root of 3, it's square root of 6. Are there any perfect squares that go into 6? No, so then I stop. Can you get off your phone? So when I look at 14, since they're both under square roots, I can actually multiply them. 8 times 5 is 40, so it's square root of 40. But the reason I didn't stop on this one is because there's a perfect square that goes into it. So if there's a perfect square that will go into this, you need to keep on going. So this is what we were doing a minute ago. 4 goes in there 10 times. The square root of 4 is 2. You can't take the square root of 10, so that recopies. Okay, this is what happens when you have a mixture of outside numbers and square roots. Sydney, pay attention. You're not. You're talking to Brooklyn. First, I multiply the outside numbers. 3 times 4 is 12. Then I multiply the square roots. Square root of 2 times square root of 3, square root of 6. The only thing you ever try to break down is the thing under the square root. Is there a perfect square that will go into 6? Well, any of these green perfect squares go into 6 evenly. So then, besides 1. 1 goes into everything. So that's it. Now, don't try to break down the 12. Sometimes students will try to break down the 12, but is there a square root over it? No. Then don't break it down. If there's not a square root over it, then don't even try to break it down. Okay, so let's try. First, I'm going to multiply outside numbers. What's 3 times 5? 15. Now I'm going to multiply the square roots. What's square root of 2 times square root of 10? Square root of 20. The only thing I try to break down is the thing under the radical. So let's look at it. Are there any perfect squares that will go into 20?
4.
4 does. How many times?
5.
5 times. And then what's the square root of 4? 2. Just a pretty little 2. Can you take the square root of 5 and get something nice? So that one just recopies. Now all I have to worry about is that 15. I'm going to drop my 15. Do you know what I might do with him?
Multiply.
Multiply. See how everything's just smushed? Since it's all just smushed, that means multiply. So it's going to be 15 times. And the only things I can multiply are those outside numbers. So what's 15 times 2?
30.
So the answer would be 30 square root of 5. This isn't that difficult if you pay attention. I just worry about those of you who are playing. Okay, I don't care what you're talking about.
We're talking about square roots.
Yes.
Jacob thought it was funny
Let's
that
talk
you
about
put a
roots,
picture
not
of roots on the rational square roots.
But what about this problem? Did you hear me talk about it?
It's 30.
30 over square root of 5.
Well, I know what the answer is because I worked it out and I wrote it down. I mean, I know that. But did you hear me talk about it? That's my problem. Number 17. First, I'm going to multiply the outside numbers. What's 2 times 7? 14. Then I'm going to multiply the square roots. What's square root of 3 times square root of 6?
Right?
What?
18. Square root of 18.
Square root of 18. I just need to make sure that you guys know it's square root of 18. Okay, the only thing I try to break down is whatever's under the radical. So let's look. Can you find a perfect square? 9. How many times? Twice. And then what is the square root of 9? 3.
Wait. Hold on. What happened to the 14?
See?
Well, I'm covering it up.
Under her finger. see?
Why'd we leave that?
Well, I'm leaving. Well, if you and Jake wanted to have been talking about the roots on number 16, you would understand what's going to happen with the 14.
Sorry.
That was my point of yelling at you. The square root of 9 is 3. Can you take the square root of 2?
No.
No, so I recopy it. Those of you who are paying attention to 16, what happens with the 14? He drops down and multiplies with the 3. What's 14 times 3? 42. So the answer is 42 square root of 2. I didn't say it was hard. I just asked if you were paying attention.
And you always say, it goes down. Well, obviously, it's going to go down.
I know, but you never heard me say anything about it on 16, which is what ticks me off.
Stop
So
talking
don't
back.
argue with me.
Sorry.
You were paying attention, so that's that. 18. Are they both under square roots? So I can multiply, and I'd get
21. Square root.
square root of 21. Now, are there any green perfect squares that can go into 21 evenly?
One.
Besides the 1.
Oh.
1 goes into everything, so don't even say 1.
No.
Then that's the answer.
It's easy.
Sometimes you can break them down, sometimes you can't. Now, based off of something I said earlier, do you know what 19 is? 7. As long as you multiply by 2 of the same thing, shoo, out he comes.
And 20 is 5?
And 20 is 5.
Well,
Now, I could have worked this out the long way. Square root of 7 times square root of 7 is technically square root of 49. But the square root of 49 is just a pretty little 7.
21, 3.
Well, let's see. So first I'm going to multiply outside numbers. What's 2 times 4? 8. Now I'm going to multiply the square roots. What's square root of 3 times square root of 6?
18. Square root of 18.
Square root of 18. The only thing I'm going to try to break down is that 18. Is there a perfect square that will go into it?
9.
9. How many times?
Twice.
Twice. You find the largest perfect square that goes in there, and then how many times it goes in there. Now, what's the square root of 9? 3. You can't take the square root of 2, so that one just recopies. And what happens with Mr. 8?
It comes down and you multiply it with 3.
And the answer would be?
24 square root of 2.
Good. 24 square root of 2. The answer is definitely not 3. What made you think it was going to be 3?
2 and 3, and then times 2 is 4, and then times 2 is 6. I don't know. I was just.
Maybe if you would have been paying attention.
Nothing.
Interesting.
Nothing.
Okay, I want to see if you can do 22.
Done.
I'm already.
I know.
Excuse me.
This year's used mainly.
He's gonna show that he's going. I'm gonna make $5 by trying
The 5.
glasses.
Alright, good.
You think you have it? Okay, what'd you get?
Wait, what?
6.
That's it. That's exactly it. So when you broke it down, Bailey, what did you have going into it?
Square root of 9, square root of 2.
Good. Square root of 9 and square root of 3. 9's the perfect square that goes in there, and it goes in there 3 times. And then, Bailey, what's the square root of 9? 3. And then you can't take the square root of this 3 and get something nice, so that one just recopies. And then Mr. 2, he just drops on down and multiplies and makes 6 square root of 3. How are you feeling?
Great.
Pretty good.
You okay? All right. You have a 2-part assignment. Your first part is the first page I gave you where we wrote this. Flip it over. And you're going to do these 6. This is like what we just kind of got done practicing a little bit, where you try to find the largest perfect square that goes in there, how many times. So there's that. And then I'll pass out the other paper, so you can be working on those 6 while I pass out the other paper, and I'll tell you what I want you to do on that one.
The other paper. What is wrong with you?
Found them. They're about to sweep the
Nothing. Nothing is wrong with me.
You sound like the joke.
I'm here to do my job, man.
Calling her loud.
Wait, let me see the
Dude, she is loud.
Well, I'm not.
I mean that in the nicest way.
Say that people try to talk over on it, and I was like,
So